I'm Wes. I'm from School of Public Health these days. I started my life in computing as a researcher, and now I'm an RSE. Hypercow, how easy could we make high-performance computing? And easy for who is the first question. And I sent the whole set of slides to my colleagues who quickly gave some constructive feedback and said it should be easy for whom, with an M on the end. So I changed that. That was helpful. What does easy mean? Is it is it for me as the kind of high-performance person in the department, or for the users? Hopefully all of the above. So easy for whom? 200 mathematical modelers in the School of Public Health, more or less. They're all coders, so they're all computational modelers, but very few have any specialist software engineering training. So you can imagine the kind of code that they're used to working with. There might be a lot of it, but how it is written, whether it is reusable, whether it is performant, are questions that are not their passion. They want to get their model done and get their answers and be able to predict and be able to do the things that epidemiologists want to do, which is modeling the spread of diseases, vaccinations and containment and all of those issues. They're mostly Windows users in a Windows domain, which again is a thing to make a note of. They're mainly R users. Okay, so I once sent an email to a certain HPC manager who none of you will ever have met or know, saying, could you help me with some Java code that I want to make parallel? Would you support MPI for Java? And the email I got back said, no, 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 on the first line, and then on the second line, no, with loads of O's. And at that time, I think it was really the advice was rewrite your Java in C in order to make it more performant, and then we'll think about letting you run it on our HPC. So I think things have moved on a little bit from that. But also, for some departments, high performance is not the be-all and end-all. It's really high throughput and getting their work done. If they've got a lot of jobs that we can quickly say, we'll get your work done quickly without you having to learn loads of new stuff. So they're running many stochastic runs. They want to sometimes run 100,000 different permutations of the same model, different parameter sets, single core jobs, just bash them through and get the answers, and they can work out how to deal with their 100,000 files that come out later on. Some of the jobs that run are extremely long as well, which is not very popular for HPC, especially if you're queuing behind them. So they want to run some jobs that may take weeks on a couple of cores and just linger in the background. We do have our own equipment. We did have it at Paddington until Imperial sold our Paddington campus, and then all of our equipment is now kindly hosted by ICT in the data center here, particularly Steve, and we are very grateful for that. The other thing is that we don't have a dedicated HPC sysadmin. We have me, and HPC is one of my sort of roles that I know a certain amount about. So we have a need here that we're not really amazingly resourced to fulfill, so we want to try and do so in a way that you might think of as slightly niche. So here we go. Here's a significant quote from a few years ago from my boss. Too many people waste time using their laptops and don't just run things on the cluster. So I knew people who needed to do a lot of runs, and if they wanted to do a lot of runs, they would borrow a lot of laptops and plug them all in, and sort of a whole desk of them all, you know, chunking away on their work, because there was a fear factor associated and a sort of technical divide. How do I get it to run elsewhere? Why don't people use the cluster or any cluster? Because it's a faff. It was just easier to do it locally, because job launch scripts are weird. These are all things I've had. Because file staging is tedious if you've got big data and you need to get it up onto the cluster to run it and put it back again. Jobs fail and I can't debug them, particularly, you know, the kind of coders that we have. It's not always guaranteed that they will sort it out so that what they're running on the cluster is exactly the same as what they're running locally. They'll tell you it is. They'll say, your cluster is broken, my code works. And I say, well, let's have a look. Sometimes because their jobs take too long and get killed by a wall time limit. Sometimes they have to wait in a queue, and they're very impatient to run their enormous workloads. So those are the kind of things that have put people off and the kind of things that we've tried to make easy. So our solution, try to make HPC feel like an extension of local work based on those things that I talked about earlier of how these people work in our department. Try and make it like a function call. They know what function calls are, so try and make it another one, like a wrapper. Just do this on the cluster in brackets. To try and run, if we can, a highly permissive departmental HPC, so not rules on wall time or resources. We'll deal with the fallout of that later, which sounds a bit scary, and there'll be some caveats on that later that I'll talk about. We are fortunate that we're quite a small department, so we can deal with cluster usage socially. People's usage is seasonal, so we'll have people who say, I need all the cluster for a short period of time, and others might need it at a different time, and most of the time we're able to say yes to that just by talking with each other. That doesn't scale, but it's what we do. We do authentication through the existing domain they belong to, so not another set of credentials. That means they can use DIDE resources. DIDE is our Department of Infectious Diseases Epidemiology. We have network shares, and the cluster gets to use them the same way as when they log in locally. Function call, I've already said that one, got that one twice. Make it look like a function call. How? Hipercow. This is our package, which is quite fun. It's a love-hate thing, whether you like the logo. Don't stare into its eyes, they're a bit dark. It's high-performance computing, and it's workbench. It's not really a workbench, but we had to find a W from somewhere. It's an R package. It sorts out all of your client stuff, so it runs on Windows, Linux, or Mac locally, and targets currently our DIDE cluster, which runs Microsoft HPC pack. It started life as a Windows-based cluster, which is unusual. I'll say a little bit more about that later. You can add Windows and Linux nodes to it, which is quite exciting. And it's not fixed to this. This is just what we've currently supported because that's what we've got. This is what easy means when you program it. So this is an RStudio console. You import the package, having installed it. You sit in a work directory that's on a network share, and you say, set me up for using the DIDE Windows node. And it says, OK. You give it your credentials. Then when you do Hipercow hello, two things happen. It runs a cluster job that does a quick bit of code to prove that it's worked, and it moves at you, because why not? So when I teach this, I get everybody to turn their speakers up, because there's something about making this fun and slightly silly that sometimes helps. If you wanted to run on a Linux node, you would just change Windows to Linux. It's that easy, except for paths in your actual code that you might have to change. So if they've written some code in a function, they'll put that function in an R file, they'll include it in an environment. Task create expression up there, we'll run it on the cluster. It submits, they get an ID. If they do log show, it streams out the text. So right as if you were running it locally, except the stream text is coming from a cluster node. And they'll get their result at the end, which is whatever that function returned. So these are all very familiar things to them to try and really make it obvious. If they use other packages, they'll be familiar with a thing called package depends. They know how to write a text file. We have another package called Conan the Librarian, which we're also pretty proud of our naming with. That does the provisioning. So they make this text file. They call this function Hipercow provision. And this is, again, the output from a cluster node that's dedicated to building packages. It's the same as what they would see locally, but the cluster node is building these packages into their network shared repository. Because packages tend to be the thing that's hard to replicate on your cluster. If they want to do lots of jobs, they'll make a data frame, which they're very good at, and there are loads of functions involving the word bundle that do all the same things as task, but multiple times over. And that's about it. So the future, there's a bit more Python now, so we're talking to Python users. We've got Hipercow Pi, which is nearly a good pun, cow pie. Do you get it? Oh, get with it. The Python users seem to like a more command line approach, so we're making it that way. That's in progress at the moment. More clusters we're going to support. There's no reason why we couldn't wire this into SSH and submit to a PBS or a Slurm cluster. If we had one, we tried to do a Slurm cluster, and it took me 4 months, and I haven't got it right yet, whereas the Microsoft one, just in case you're skeptical, which a lot of people are, it takes about 10 or 15 minutes to set up a full cluster, maybe another hour, and I added 80 nodes to it. So it's unusual. You don't see many of them in the wild, but it's a surprisingly pleasant experience to work with. So summary, that was our effort to make HPC very, very seamless, almost unnoticed. Try to make technical tasks more fun, remove the fear. Microsoft HPC, weird but wonderful. Windows and Linux nodes with one head node, and you just choose where your jobs go to is quite cool. Quotes of the week, wow, I can't believe it's this easy. Someone actually said that. And someone else said, it seems to work, surprisingly, which you can't please everybody. The one caveat at the end is we are a smallish department. Not everything here will be your thing. Not everything here will scale to a whole campus. Perhaps not everything should. There's a compromise there of trying to work with your users as an RSC and try and put tools into their hands that they can use really quickly. So that's what we try to do. Thank you.